Hello, in this video we will discuss about how to draw the mechanism of free radical reaction of halogenation of alkane. Now halogenation of alkane we mean substituting the halogen uh, instead of hydrogen of an alkane to result in the formation of alkyl halide. We call that as halogenation. Now to discuss this, let us pick a simple example, that is, say, chlorination. Chlorine is the example of halogen. Chlorination of methane is the simplest example in this category, the chlorination of methane. This reaction takes place, say for example, here we take a simple example, methane reacting with chlorine in presence of sunlight, which is represented by H nu, sunlight, to replace hydrogen of the methane by chlorine, resulting in the formation of chloromethane, and this hydrogen go with one of the chlorine to give HCl. So this is the product. The chloromethane and hydrochloric acid is the product. Now we wanted to discuss the mechanism of this reaction. Now to talk about the mechanism, this is a free radical chain mechanism, involves various steps in this reaction mechanism. The first step we call the chain initiation, or simply initiation step, chain initiation or simply initiation, in which the radical is generated. So in this case, the chlorine is the starting material, which we can write the uh, Lewis structure of the chlorine as Cl and Cl bonded by the single covalent bond. Now in presence of sunlight, say H nu, this uh, chlorine-chlorine covalent bond will break by homolytically. Homolytically we mean one electron go to one of these chlorine and one electron will go to other chlorine. So you check the half arrow. So one electron and one electron, that is being distributed to each of these chlorine. So the result is the formation of chlorine radical. Okay, this is odd electron, we call that as chlorine radical. Two of these will be generated, and simply we write that as the chlorine radical, right? Or we can write that as the chlorine radical. And we know that this chlorine radical has other three lone pair. This is the odd electron that makes it as the radical. Chlorine free radical is generated, two of these will be generated, and this reaction is called chain initiation. Now, whenever there is an initiation step, how can we identify that? From the non-radical species, the radical is generated. And that means what? In the reactant, we do not have the radical, but by the homolytic cleavage, we generate the radical there. We know that is the chain initiation step. So if you need to identify which of the following is the chain initiation step, then how we should go with? You do not have the radical in the reactant, but you generate the radical in the product. If we can represent simply this reaction as, if you don't want it to show the lone pair of electron, this is chlorine-chlorine bond. One electron go with one chlorine, one electron will go with the other chlorine. That happens in presence of sunlight to generate two chlorine free radical. No radical in the reactant, radical in the product. This is what we call the chain initiation step. Now, once this chain is initiated, second we call that as the chain propagation step. This is the most important step, propagation, that will make the chain reaction continue in the process. Okay, so in chain propagation step, what happens is our substrate or alkanes, that is the substrate that we have used, that is what? Methane. That is what we are using in this particular example. Then it will be reacted with this chlorine radical that is generated in the chain initiation step, this chlorine radical. Then what happens is, in this step, this chlorine radical causes the cleavage of this carbon hydrogen bond homolytically. So that means what? One electron will go to hydrogen, one electron will go to carbon. That is because of this chlorine free radical will cause that. Now once this hydrogen radical is generated, this radical then combine with this chlorine free radical to form the HCl bond. So the result in this case is you have now generated the new radical. There was a chlorine free radical, now it is generating HCHH, or you can say that is a methyl free radical, and hydrogen and chlorine now is forming the HCl molecule. So the chain propagation step is one important step in which one radical is used up and other type of radical is generated. There here chlorine free radical is used up and methyl radical is generated. This is one of the chain propagation step, and there are multiple chain propagation step. In the second chain propagation step, what it does is this methyl free radical will be used up. Say here HCHNH. This is the methyl free radical which is generated in the first propagation step, and then it will react with chlorine molecule. Now there are millions and millions of chlorine molecules that is the reactant there, so some of that will break to generate the chlorine free radical, but some of this chlorine molecule then react with what? This methyl free radical. Then what it does is it will cleave this chlorine-chlorine bond so that methyl radical will combine with this chlorine radical and other chlorine radical will be generated. So it will cause the breaking of this chlorine-chlorine bond homolytically in the second propagation step. So what is the result? How is the outcome here? You have now chloromethane, that is the desired product, and also chlorine radical is generated. Now if you check these propagation steps A and B, this A, B step will continue, right? The methane molecule will be used up to generate the methyl radical. Methyl radical react with chlorine molecule to generate the chlorine radical, and this process will continue until you have the enough substrate there. So once the substrate is all used up, then it will have to go to the termination step. So this chain propagation step is the step where you have generated your product, you have generated the side product. That is how the reaction takes place. Now ultimately this chain reaction, the radical chain reaction, has to come to the end. We call that as the termination step. Let me remind you one point here. Sometimes in the exam you will be asked which of the following is the chain propagation step. So how do you identify the propagation step? Is in the propagation step you have one type of radical in the reactant, and you generate other type of radical in the product. Okay, remember that in chain initiation step there is no radical in the reactant, but you generate the radical in the product. That is the chain initiation that trigger the chain. In propagation step you use one type of radical, you generate other type of radical. You see there, methyl radical used up, chlorine radical generated. Chlorine radical is used up, methyl radical generated. That is the chain propagation step. Now ultimately, in order to conclude the reaction, the radical needs to be used up, and that step is what we call is the chain termination step, or simply termination. Termination, again, as I said, that means the reaction needs to come to the end, right? That means what? The radical will have to be used up. So there are varieties of termination steps is possible, in which the radical will be used to generate non-radical species. One of the termination step which is very useful will be, say, the methyl radical generated in the propagation step may combine with chlorine radical. This one electron from here, one electron from here can combine to give what? Chloromethane as the product. It is very useful termination step. You get the desired product. The other possibility is combination of these two methyl radical. Okay, these two radical will be used up, and these two will combine to get a bond, and the result is the formation of ethane molecule. Now, this is not a desired product, but sometimes that can happen. Undesired product, unnecessary product. The other termination step you could argue is, okay, here is chlorine radical. Two chlorine radical may combine to give the chlorine molecule, like forming the bond, chlorine-chlorine bond. So, which is also not what we wanted, but that can happen. And sometimes some termination steps, even these radical, that is how the generated radical, say for example methyl radical that is generated in one of the propagation step, may combine with wall of the containing vessel in the reaction vessel, forming this radical will be used up, will form some certain type of bond with the wall of the vessel as well. Again, this is not what we wanted, but that can happen. So these all are possible termination steps. But however, in your exam, if you are asked to draw the mechanism for the chlorination of methane, you can give one or two of these termination example, and propagation you have to include both, and of course initiation is desired. This is how you can discuss the uh, mechanism for chlorination of methane. One more point I wanted to point out here, sometimes in the test the question can be, which of the following is the chain termination step? So how do you identify that? In termination step, you have the radical in the reactant, but in the product there will be no radical. Look at this one here, this product, no radical there. This product, there is no radical, no radical there. You have the radical that will be used up to form the non-radical species or to form the product. That is how the mechanism happens. Now, this simple example you can extend to various types of the halogenation mechanism. And again, say for example, one problem, see, suppose you are asked what is the mechanism for this halogenation reaction. Say for example, toluene reacting with, for example, bromine in presence of sunlight to give, let's say, yeah, you have CS2Br and SBr. This is the product. Okay, now you are asked to draw the mechanism of that, and you may be wondering, well, how do I do that? We did not do that. But if you closely look at this one here, uh, this reaction is very similar to the one we just did for the chlorination of methane. Only the difference here is, instead of chlorine we are using bromine, which go exactly in the same way as chlorine, and instead of methane you have used here toluene, which has what, 3 hydrogen, and instead of 1 hydrogen we are using the benzene ring. That's all. So instead of 1 hydrogen, just keep on writing the benzene ring, and instead of bromine you write the chlorine. Instead of chlorine you write the bromine. That's all you need to do, right? Bromine here. And the product, you see, you replace the one of the hydrogen by bromine, and then result is, again, you have 2 hydrogen here and bromine here and SBr. Again, if you are asked to draw the mechanism of this, how do you follow that? Again, there are 3 steps that you need to follow. One is called chain initiation. How do you do? What is the initiation step? You have bromine molecule in presence of sunlight that will cleave to give the what? Bromine free radical. As we generate the chlorine free radical, here is bromine free radical. Now this bromine free radical then go into the second step called chain propagation. Okay, propagation step, in which you have this